there is a change of state of a system or a substance, what is happening at the boundary? Rather know what I want it to happen. And is there a one single happening which I am happy with, or I may be interested in having a different happenings. Okay, so the happenings are our benefits. I'm not interested in what is the change in system state. What is the state change in system or a material state? How the pressure is changing, how the temperature is changing. Most of the times I'm not interested in that. But I have to do that one because there is some happening which I love it, I enjoy it. And you see this one, suppose all these happenings are the one which consume our resources. The resources could be natural, renewable, non-renewable, fossil, anything. I'll give you one of the interesting example of the ancient way the people enjoyed these happenings. And I explained you wind energy is one of the most natural decided by the sun. A good breeze of wind always a resource for many people. Different people used it in different way. And let me show you one of the most interesting ancient. These are the ones typical buildings which you see in Persian countries or all the hot and desert areas or so. They used to have a huge pillar, so many openings all throughout. Now you see they have an objective of changing the state of a wind, but what happens when they want to when they change the state? What kind of state they want to have it? A change in state they want to have it to get some happening. Very interesting. That's how thermodynamics is a natural characteristic, biological characteristic of a human. Such a big buildings, I'll show you more and more things. So these kind of structures, and there are very peculiar structures happening. So these are called ancient green methods for better living. These are very popular and started as early as 13 BC, 1300 BC, and mostly started in the Egypt. Okay, but slowly they percolated across. An invention by one particular extrasomatic human percolated across all those places. What is the requirement for which they built like this? The great thermodynamic happening you can see. In the Persian, they call it as a bagdir, badgir. Bad means wind and gir means catcher. This is a wind catcher. Whatever wind blowing, no, it will catch. And why they are catching the wind? What do they want to do? Because somebody may catch the wind to get a pumping of water or to generate electricity. Are they interested in the same kind of happening or something very different? Very early, when the people do not know mechanical power, these people were constructing the houses like this. Okay, and then in Arabic it is called a malkaf. So every part of this world, they were in need of wind catchers. What are these particular one? Harzil in Arabia. So almost all the settlements of the world which have a similar climatic conditions, they were copying, developing, investing a lot on a big construction of these houses, and which started as a badger, which means wind catcher, but various countries which are in need of this particular thing. What is the commonality of all these countries? They are dry, hot summer conditions, and there is no mechanical power available. Living in such a hot and dry environment is almost impractical, and especially the human being an extrasomatic, he has to have some kind of outside body energy to this one. You see some of the construction. So there are so many ventilators. You see this one, all the four sides there are windows. Why? They don't know what is the direction of wind any time. They don't want to lose wind coming from in any direction, they want to catch it. So that's how they had a four sides, or they had a cylindrical structures with an opening. Whatever may be the direction of wind, this wind will enter into their house or into this wind catcher. And if I show you thermodynamic diagram purpose or a happening for which they are doing, you will surprised to see how natural is thermodynamics. You see this particular one. If I give an equivalent thermodynamic diagram, so there will be an opening. If this is the wind direction, the wind will enter through this one. They have an explicit partition. At the center of the house, there is a pool of water. Now this dry hot wind is made to enter. After entering, they are making a path to follow. You see this one, it takes a U-turn, and at the bottom of this one there is a water pool. What will happen? The hot wind, dry wind enters. It will have a kind of contact between the water surface. Because there is a contact, the concentration difference will try to develop an equilibrium between the wind and the water. So because of which what will happen? Water will try to evaporate, and evaporating water will decrease the air temperature and water temperature, and this entire thing will leave. Now most of the time now the people will live in this particular portion where they will have a cold, humid air for a happy living. Not only that, there is a third one. In a hot summer also, they'll get a drinking water reasonably cool. Now this is the one which led to the development of desert coolers in the entire world. Technically all the desert coolers are based on their inventions. The origin of desert coolers in the entire globe is because of their innovative trial of barriers. Now here they are using the wind power to cool them, to cool their body. Basically they want a kind of heat transfer to occur whenever the change of state of wind. Now you see what is the incoming wind? Incoming wind has a high temperature, very low humidity or a zero humidity. What is the outgoing air? The outgoing air will have a relatively low temperature, high humidity. And the wind which is in this particular direction, in this particular location, what is it is having? Low temperature, better humidity, and they are happy. So they have changed the state of the wind from inlet to the exit. But what is the requirement? What was happening with them? What did they made it to happen? There are two things happening. One is there is something happened to the air. Because something happened to the air, something is happening to their body also. Okay. Now the same wind and same wind power, the people can use in a way totally different. You see this one. What is the modern green power? So if there is a big wind power, I'll have a big wind farm, number of wind turbines all over, and all these wind powers will generate electricity. I'll have a substation which will capture all this power and transmit it into electricity. Now you see this one. The same wind, when I changed the state in one way, I was happy to have a heat transfer from my body. I could produce a cold water. These are all happenings. Something happened to the water in the well or a tank. Something happened to the wind. Something is happening to my body. All these three, there is something happened. Each one changed their state. But in this case, what I am changing? I am not changing the temperature of the wind here. I am not interested in changing the humidity level. What I'll change? I'll decrease the pressure. I'll decrease the kinetic energy. All that kinetic energy will be given to the rotor. Then I'll get the electricity. You see this one. Sometimes the natural wind is used to generate the electricity and enjoy the electricity, but you can use inverse of that one also. You can see this peculiar combination which I am giving. How crazy are we to change the state of a system? Now you see all the electricity is used to blow a cold air so that she will be happy. Now here the natural wind velocity is converted into electricity. Here the electricity is converted into a higher velocity with a low temperature. You see this one. A system will change its state. System is ready to change its state. But whenever there is a change in state of the system, there are some happenings. And these are the happenings which will change our lifestyle. You need to assess what happening I want when the system is changing a state. Or for a given happening, what kind of state of change of state in the system will be the beneficial. In fact, the first culmination of all the knowledge is to create this kind of things. That's why I'm saying, I'm questioning, what is happening whenever there is a change in state? Can you recognize what all can happen? Then you can choose. Sometimes I want this to happen. Sometimes I want that to happen, because in summer I want this, in winter I want that. Okay. You are some other weather, some other requirement. Very important that system will change its state and PVT, pressure, volume, temperature. But when it is changing its state, you are looking for different benefits. A system may change the same state from 1 to 2, but sometimes you are interested in one happening, sometimes you are interested in the other happening. You see this one, any of these happenings are useful for engineering world. That is the one. Why I'm making the system to change, why I'm concentrating in the state of change of state of a system. Why? There is all these happenings are useful for engineering world. Okay. What are the main engineering requirements? You see, does it consume any resource? Then I need to think techno-economically. So does it consume any resource for which I have to pay money, or is it naturally coming? Then I'll have to think twice, because I want some happening and I have to pay for the happening, and then I'll have to be very careful about what I am losing, what I am gaining. What causes these happenings? What is causing these happenings which I am going to like it? So there are three things which are happening. Whatever happens during a change of state, is it important or useless? The second one is, of course there is a use, I should go. No, there is useless, I should not go for it. Why I don't want to go for it? If something happens by consuming a resource, why should it happen at all? If something happens with a use and there is a consume of resource, then I need the techno-economics. How much benefit I am getting, how much resource is consuming, and who is causing this particular happening, and how to cause that. I said it no, they evolved to few hundred years to come up with such a beautiful idea called a backgear. How many years, how many generations worked together to perfect such a nice system so that they can live happily such a hot, dry environment and without any problem. Okay, then only they started living happily. Otherwise, they must be subjected to many diseases, maybe entire thing. The first and foremost, no, all these happenings are creating a thermal inequilibrium, isn't it? So the wind has a uniform temperature. The moment there is a wind catcher in between, there is an inequilibrium created in the wind. The wind is now changing its temperature, thermal inequilibrium. Means I'm purposefully creating thermal inequilibrium because that is good for me. And I was subjected to very hot environment. I'm not happy. I want to change, disturb this inequilibrium and subject it to a cold air. Then I'll evolve into next inequilibrium, isn't it? So to enjoy, I am creating a thermal inequilibrium, or sometimes I may create a mechanical inequilibrium. If the wind has a uniform velocity, uniform pressure everywhere, I get nothing. Suppose if I put a windmill, what it will do? It will create a mechanical inequilibrium. The wind will lose its kinetic energy, wind will lose its pressure, and because of which what I am getting? The difference of energy I am getting to the rotor. That rotor can be used to drive the generator, I'll get electricity. So, and by changing the temperature of the wind, I can enjoy a nice environment. By changing the mechanical properties, I can get a electrical power. Sometimes I may change the chemical inequilibrium, isn't it? After catching the wind, if I don't think about the wind passing over a water pool, I'll not get any benefit. All the idea of constructing such a beautiful wind catcher will not serve the purpose perfectly. You imagine that wind catcher with and without a water pool at the center. If there is no water pool in the center, the people who are living in the house will be subjected to some air velocity, but that is a hot air and that is not a good thing. And suppose if I put a small water pool, I create a both thermal inequilibrium leading to chemical inequilibrium, means some of the water is evaporating. Evaporating water will change the temperature of the water, also change the temperature of the air like a desert cooler. You see this one? So unless I create an equilibrium in the system, I cannot enjoy. All my enjoyings are somehow disturbing the equilibrium. You see this one. Zeroth law talks about things tends to equilibrium, but a human wanted always opposite to what happens. Whatever he can enjoy is by creating an inequilibrium. He cannot be in equilibrium with a hot environment. He cannot be in equilibrium with a cold environment, and both are dangerous to him. He has to create an inequilibrium, and which requires a change of state, and which requires a consumption of a resource, and which requires a physical structure to be invented like a bath gear. Okay, so without inventing that one, it happens. Okay, so any combination of above, I may have a thermal and mechanical inequilibrium. I may be interested in mechanical and chemical inequilibrium, or a chemical and thermal inequilibrium. So you can have a different thing. These happenings are actions, path functions or interactions. All these happenings, no, these are kind of an action. Something happening to my body, something happening to the air, something happening. All these are called actions. Strictly speaking, no, all these happenings are literally speaking verbs. They're not nouns at all. And they're all totally a path function. You see this one, same wind velocity, same wind kinetic energy. In one case, I changed the path, I got a cooling effect. In the other case, I innovated a wind turbine that is doing some other process. I'm getting a mechanical power and electrical power. So the happenings and actions, no, they depend upon how do you take the system from state 1 to state 2. Whenever you are changing the state 1 to state 2, what is the path followed in between will decide what kind of happening. Is it required or useless? Okay. Now, the present only during the change of state. All these happenings will occur only there is a change of state. If the system doesn't change its state, there is no happening. There is no enjoyment. There is no inequilibrium. Why? Unless there is an inequilibrium, there is nothing like an happening which I enjoy. You cannot generate mechanical power from the wind unless you change the state of the wind. Okay, you need to see all the human activities will have, you understand something, try to do opposite to that, then you will enjoy the deal. What action is, now at the end of the day, the thermodynamics is coming to more precise. Which of the happenings can be called as a work transfer? The bath gear, whatever bath gear doing, no, wind catcher cannot be called as a work transfer. I am not interested in the work transfer at all. I am only interested in some kind of heat transfer. The wind is cool, water is cool, my body is cool, everywhere cool, cool, cool. On the other hand, a windmill cannot be, windmill is, the idea of windmill is not to cool the air or not to cool the blades. The idea of windmill is different. So you need to know exactly which action is called a work transfer. Sorry. What did I do? Is it okay? Which action is called a heat transfer? Sorry. Which action is called a heat transfer? You see this one, windmill and bath gear. There are two extreme things. Okay. And which action is mass transfer? So in a bath gear, there are two things happening. There is a heat transfer. That heat transfer is provoked by the mass transfer. Unless water evaporates, heat transfer will not happen. Unless there is air continuously flowing, mass transfer cannot happen. Why? Once there is a packet of air comes and sealed room is locked, what will happen? The wind and the water will come into chemical equilibrium. Afterwards, nothing will happen. So that's how there should be a continuously air coming in, continuously air losing. That's why what will happen? There is a fresh air which is dry, dry, dry. Because of which there is a constantly inequilibrium is maintained between the water and the wind. So which will drive the water and the cooling effect will come, I'll be happy. So that's how you need to know what are these three actions, how do you precisely know them. And you need to know how to differentiate a given happening is a work transfer or a heat transfer or some kind of species transfer. Mass transfer means a kind of concentration in equilibrium process. Now first let us talk about the mechanical work transfer which is well taught to us in the school. Perhaps as I was saying, no, our entire thermodynamics, one single reason why thermodynamics evolved is people wanted a motion. The motion comes out of a mechanical work. That's how even in the school, okay, work is a mechanical concept given by the expression. What is the work is defined as? The work is if there is a force, if the force is continuously getting displayed, and if the force has some component in the direction of motion, then only there will be a work transfer. All of you know work is said to be done by a force when there is a displacement of force in its own direction. If the displacement of force in the direction of force is 0, then there is no work done at all. There has to be a displacement in the direction of force. That is what is called a mechanical work. Most of us are interested in this kind of mechanical work to start with. Okay, so that's how you see this one. A small infinitesimal work done is defined as dot product or a scalar product of force vector multiplied by a small change in displacement, small displacement. This is the ds is the infinitesimal displacement of force vector, and the f is the magnitude of the force, and the work is defined by the dot product only. Why? If the force and displacement are not in the same direction, you get nothing. Okay, so that is the mechanical work which we are not required. Now we need to understand. So if I want a finite work, then the force and displacement both are vectors, and by changing the displacement of a force continuously I can get a work, or by changing the force value continuously also I can get the work. There are two ways I can get the work. So I need to understand explicitly how I can generate a force using a natural resource, how the system pressure, volume, temperature will create a force. Okay, at the end of the day I want to create the force through system or through a substance. That's how one has to have a global link between what is called ultimate mechanical work and what you can generate or what can create. All of you know F is a force vector, S is a displacement vector, then work is a scalar product. Unless there is a component in the direction of force, there is no work at all. The dot product is very important, cos theta. Okay, the force components along the displacement vector only can do the work, isn't it? If the force is the totally in an opposite direction, you can't do any work at all, and you need to be very careful in the designing everything. So the force component perpendicular to the displacement vector cannot do work at all. You are stressing a lot. Okay, so one has to understand this particular one, and this relationship will be useful to find the work required to raise a weight. Let me explain this entire thing in a simple way. Give me the whiteboard. Okay, now you see this simplest device. After all, how much engineering, how many years we'll learn. So let us say a person, all of you know in your mechanics, is carrying a big suitcase on his head and he is walking through, and fundamentally he is not doing any work at all. And if at all you want to prove that he is doing a work because of the weight, the friction force between his leg and the uh, floor is increasing. Now higher the force, higher the displacement. This is the most ridiculous way of lifting a weight. And again, many people say that you are not doing a work at all because the weight is in this direction, he is moving explicitly. In order to know that he is doing, and this is the displacement vector. Now what is the best way to do this particular one? This is a stupid way. And it took so many years to invent a better thing. What is the better condition? If you pay a little more, there are wheels and there is a handle, okay, and you will nicely walk through and carrying this particular one. Now you see this one, the weight is in this direction, and depending on the weight is equal to mg, there is a friction force which is coming. This is the friction force, and this is called a rolling friction. Now what you are moving, why are you doing the work? Because there is a displacement in the direction of the force. Unless you apply a force equal and opposite to this one, you cannot, isn't it? So this is the extra force you are applying, and that force is getting displaced in this direction. Now at the end of the day, what is the force which is doing the work? You are applying a large force vector, and the component in this direction only doing the work, isn't it? Unnecessarily on your hands there is a stress which is creating because of you are having it. You see this one. What is the most modern costliest suitcase you have? You have a 4-wheel suitcase, the wheel here and a small handle like this, and the person will just push it. Now you see this. So the total force which I am applying with my hand or muscles are doing work. And to do this work, no, I need a little energy to be consumed. I need not spoil some muscles. Now, so in all the cases, I'm doing the work. I'm shifting the suitcase from place 1 to, sorry, I'm shifting the entire suitcase from place 1 to place 2. Now you see this idea, appreciating the scalar product, and I wonder how many years and human intelligence takes it. Why did not we invent the four-wheel suitcase immediately? Okay, so very costly suitcases have this force thing. So the ultimate work required is same, but depending on this one, you will strain somebody. This fellow will suffer a lot to do a work, and this is a relatively easy. This is the easiest. Even an old person can take a large weight without any problem at all. So all this is because the work which you are doing is only this work. Okay, so this is only the work which you are doing, and if you are applying a force, very large force, but the component of that force in the direction of displacement is very small, means obviously you are wasting all your resources. You are troubling yourself, you are breaking your bones. All this is a stupid thing. So that's how the scalar product has so much implication. And at the end of the day, you are lifting a weight and you are taking a weight from one place to another place. What thermodynamic specialists thought about it is the raising of weight is one of the most important and easily understandable work which happens in the world. That's how force into displacement is so nicely utilized in the weightlifting. You see this one, all these three pictures are lifting a weight using the principle of the scalar product of force into displacement is work, isn't it? Okay, so that's how the thermodynamic come up. Sorry, yeah, go to the. That's how thermodynamics came up with a nice concept to have a broader version of this particular work definition. So to stretch a wire or to move a charged particle through magnetic field, all these things are a kind of force into displacement. Either raising of a weight, stretching a wire, or a charged particle moving in a magnetic field, etc. All these things are force, scalar product of force and displacement, force and displacement. So that's how people wanted, or a thermodynamic wanted a more global things. You see this one? Thermodynamics is more wise and broader definition. And only the force into displacement is the work is not enough too. Because many a times things may not be straightforward. That's how a thermodynamic system doing a work is defined very differently. Okay, how to define the work in terms of system, surroundings, and properties of system. That is the goal of thermodynamic system doing the work. Unless there is a change in property of a system, there can't be work, there can't be a happening. And whenever there is a happening, how the system is changing, how the surroundings are changing. What is the interaction between the system and surrounding? So force into displacement doesn't talk about all the things. You see this one? Whenever I say that the work is a scalar product of force and displacement, I'm not bringing the holistic way of developing a system to do work. So that's how the thermodynamics wanted a more perfect. And also, what kind of systems can follow the definition mentioned as a mechanical work? Can I say all the thermodynamic systems are obviously doing a force into displacement? All the works which we are enjoying will have a clearly force multiplied by displacement, or inherently they may be having, but explicitly it is difficult to identify. The force acting on a solid body and the force is moving in the direction of force itself will tell explicitly. Now you imagine, so somebody is doing a work, somebody is burning all his calories, depending on your definition. You see this one, can you go back to the whiteboard please? You see this particular one, some can, at the end of the day, there is a stress, there is a power, there is energy of muscles consumed, etc. But one says there is no work, one says there is a partial work, one is total work. So that's how a mechanical work definition is a very limited. It doesn't take the holistic perspective of doing many things. That's why thermodynamics wanted a more global. Go back to the lecture please. Okay, so they wanted a more perfect definitions. How to get the perfect definition is the one. Okay, there is a displacement of force, and this is called the displacement work. Whatever a mechanical work or whatever work you learned in physics, no, this is called a displacement work. Why? There is a clearly a force displaced, and you are clearly seeing that there is a force and the force is displaced. And many things, no, the displacement of force is not explicit. Sometimes it is almost impossible to find out the force and the displacement of the force, but you are getting the same effect as a force into displacement. So in all those cases, quantification of work will become a very difficult, or people will wrongly interpret it. So that's how, what property of system are required to compute the work. So whenever I want to know what is the work done, which properties of system should be used to calculate this has done this much work. Okay, so that's how the people wanted, or the thermodynamics wanted a more global thing. What is called a need for a general definition of work transfer, not just scalar product of force and displacement. No doubt, inherently, when I dig, understand for a 5 days, 10 days, or 100 days, I may see force into displacement. But that is not a right way. You need to have a definition which will be more crisp. Okay, a general definition of work in terms of system and surroundings. So a definition should have a what is happening to the system, what is happening to the surroundings. Okay, this is very important. Without having these two and defining a work transfer is not a complete knowledge. A versatile relation between the nature of a change of state and the quality of work transfer. This is also very important. So what is the path followed by the system because of the change of state? How it is influencing the magnitude of work transfer? So one has to understand, because at the end of the day I am consuming some resources. Okay, so let me talk about little more. To identify more actions other than displacement work, there may be many actions which are equivalent to raising of a weight. All these are, there is a work, but I need to know more than a force into displacement. I want to know a better definition. So what is the difference between capability of, this is very important to know. If I have a 25 kilojoules of coal, okay, I have a coal which has a calorific value of 25 kilojoules. I have an electric battery that also has a 25 kilojoules of electricity. Can I say both of them can do the same amount of work transfer? What is the difference between these two? So your definition has to be much more deeper than just force into displacement. Okay. So suppose if I have a 25 kilojoules of kinetic energy and 25 kilojoules of potential energy, are they same? Or 25 kilojoules of kinetic energy is better than 25 kilojoules of potential energy? All these things are very important to define the happening called a work transfer. So work done by a reciprocating engine or a work done by a jet engine, can I say both are almost same? If it is a reciprocating engine, how do I calculate force displacement? If it is a jet engine, how do I calculate what is the force and displacement? So can I say that unless engine is attached to the car, I cannot get the force into displacement? Unless the engine is connected to the aircraft, I don't know what is the work done by the engine. That is very difficult. While developing the engine itself, I should know what is the work transfer possible. So that's how the people wanted a very general definition because of so many arguments. Why I'm giving so many arguments, unless you have so many questions, you will not appreciate this elaborate definition of thermodynamic work. So again, as I said it, no, international committee in the leadership of Maxwell and great scientists accepted this definition. See the definition, very important. This is one of the most powerful definition which led to doing many innovations. All are equivalent to each other. They may not be exactly same. So what is the definition? Positive work is done by a system during a given process. Very important. What is the meaning of a given process? A system should change its state step by step, one state to another state. So to reach state 1 to state 2, there is a perfect relation between how the pressure, volume, temperature are changing. That is what is called a process. But when do I say a given process is doing work? Only when there is a force into displacement and scalar product should be non-zero. No, no, no. You need not be such a precise. You have to be more generic. What is that generic? You see the very beautiful sentence created by these people. When the sole effect external to the system could be reduced to raise of a weight. Very complex definition. Now, scalar product of force into displacement is so easy. But if you use that one, you cannot develop so many products, so many possible work equivalents. Now, this definition may appear very arbitrary. Why he is using so many terms? So simple to write it, force into displacement. Why he is saying that positive work is done by a system during given a process when the sole effect external to the system could be the raise of weight. What is the raise of weight? Why he is using the word raise of weight? Raise of weight is the one which is obviously force into displacement. I showed it to you. Raising of a weight is an obvious force into displacement. If I perfectly raise a weight, now you can see this particular one. I am applying a force equal and opposite to the weight of the object and I am moving up and up. So the force into displacement is so explicitly whenever you have the entire thing. And this is forced on the readers / to identify all possible work actions in the engineering. Why such a definition is forced on us is, so many actions which do not look like a scalar product of force and displacement, but they are actually equivalent to that one. Then you can have, in fact I was telling you Thomas Savery's story. Thomas Savery was working in a army, and that time the army was using the boats driven by the slaves using the pads. Okay, so now he said ki no, why are you teaching them? It is cruel to use the so many workers driving your rowing your boat. What I want is, I wanted to invent a wheel which will drive the entire vehicle. That wheel can be driven by something else. Then he was thrown out of the army. Are you stupid? How can you have work without a force and displacement explicitly? The wheel is going in a round and round and round. Where is the force? What is this nonsense? You must be a crazy, or you must be a mad fellow. That's why you are talking. The great Thomas Savery was thrown out of the army because they could not understand anything else also can do the work. And he came out, he developed the wheel which can drive the boat. How to drive the wheel? He invented a steam engine which eventually drove the entire world. Very important. If you depend upon the Newton's laws like force into displacement only, perhaps the number of the products possible will be very limited. You have to catch so many slaves who will apply a force in the direction of the entire thing by rowing the entire boat. That is only the way of getting the work done. There is no other work at all. Very unfortunate. Otherwise, you put lot of curtains to your boat and all these curtains will try to block the wind. Now the wind is putting an action. As a reaction, boat will move forward and force into displacement. So otherwise, I don't see anything else possible. You imagine. So you need to think much beyond. In fact, it is the life story of Thomas Savery, which excited everybody. No. We need to have a work definition much more elaborate, much more generic, and it should take many ways of achieving force into displacement, not just by a force and displacement. So all this led to. So will it consider mechanical work or not? Whatever this definition, will it consider mechanical work is also work or not? Okay, so any effect which is equivalent to raising of a weight should be called work. That is the precise statement of this one. Unless it proves that force into displacement also a part of this, I cannot consider this to be work. So that's how people wanted to do a construction. Let us take a perfect mechanical work generating system, exactly force into displacement. As I did know, you can take a rowing a boat or anything, but I am taking one of the fascinating example of perfect force and the displacement of force in the direction of force. Okay, so the example I am taking is some kind like a missile launchers. All of you know this is called a missile launcher, which will push the missile out of it. And you see this one, the force and the displacement are in the same direction. Let me show you working of this particular one. So this is the telescope to launch it. This is called a launch tube, and this is the one inside which there is a missile. When you push this particular launch tube, it will eject the entire thing. These are called the ballistic missiles, which are very popular in an ancient defense system. Okay, you see this particular one, a missile come out of this particular launcher. Okay, now you see I am making a configuration. I am trying to explain. The missile launcher is the system. The missile is the surrounding. Okay, so the before triggering, this is the position of the entire thing. Okay, and the moment I trigger it, this is the trigger, isn't it? Okay, if I trigger it, now you see this one, the displacement of surroundings has increased. You can see this particular one. The initial surrounding was at this point to this point. After triggering, the entire surrounding has moved. Now you see this one, what is the system? The missile launcher. What is the surrounding? Missile. And the missile launcher, which is a system, and missile is a surrounding, these two are interacting with each other. That interaction is something like after triggering, there is a plunger coming out and pushing the entire missile out. Can I call this is also a thermodynamic work. Here you can see explicitly there is a force F and getting displaced to a displacement S. Obviously there is a force into displacement. In fact, no, it is a perfect force into displacement because both are collinear. The force is moving up its own direction. There is no component problem, nothing. Both are collinear. So it is obviously a mechanical work. Will the thermodynamic work consider this to be a work? Because the thermodynamic work doesn't say that force into displacement explicitly. What it does something like the sole effect external to the system, means on the surroundings, could be reduced to raising of a weight. This entire effect should be translated into raising of weight. Then only I can call it as a thermodynamic work. Mechanical work says a force into displacement, and thermodynamic work always demands of raising of a weight. Now you see this one, I am making a construction. So instead of a missile, I am replacing the missile environment with a special environment, which is a L kind of fulcrum having a big weight on this. Okay, so I have replaced the missile surrounding with another surrounding, and so then now what I am doing, this is before triggering. Now you see this particular one. So the moment I trigger it, what is happening? The entire weight will get lifted. Okay, so now you see this one, there is a displacement, and this effect is called the raising of a weight. Now all of us can easily say that, so whatever system can do as a mechanical work, same thing is done equivalent to this. What is the meaning of the definition? That this raising of weight should be equivalent to that mechanical work. So whatever this is producing is equivalent to raising of weight. That's what is called a thermodynamic weight. You don't have to look for the force, displacements, etc. Any effect totally 100% is equivalent to a raise of weight that can be a work done. Now let me explain a point by point. So the mechanical work is a thermodynamic work and vice versa. Why? Because all the mechanical work can be translated into raise of a weight. You see this one, the displacement of plunger is same. Same displacement of plunger with the same force did an equivalent work by lifting the weight. So there is no difference between mechanical work and thermodynamic work. So because thermodynamic work is satisfying the mechanical work, at the first level I can accept this definition, and it talks about more. So this is the one. In the first case, as a mechanical work definition, it is force into S, F into S. But in the thermodynamic work, a weight W is raised through a distance of S1, isn't it? So these two are equivalent. So the 100%, entire F into S is equal to the raising of the weight. That is what is called could be reduced to, means 100%. Sole effect is the word which is used in the definition. Okay. Similarly, let us say I have a battery and I am using this particular battery and coupled to a convector. room convector. Now if I take this particular definition, now what is crossing the boundary? And there is a confusion. What is the crossing the, okay? So can I get a pen here? On the document. Okay. Now, is it a pen? Now, suppose if I draw a boundary around the convector, okay. Now, I'll say what is crossing the convector to the room. And another question is, who is responsible for whatever is crossing from the convector to the room after all this battery? Okay, this is the battery whose boundary okay, this particular boundary, whichever you are looking at already, see there is something crossing the battery, but this is responsible for something else crossing the convector. Now the question is, what is crossing the boundary is same as what is boundary of a battery, sorry, whatever is crossing the boundary of a battery, is it same as whatever is crossing the convector? Can I say these two are equivalent? At the end of the day, they are equal in magnitude perhaps. So this is where thermodynamic definition works. Okay, whatever crossing the convector boundary, whatever crossing the boundary of the battery, are they same or they different? What is crossing the battery? Because here you don't see any force and displacement explicitly. Okay, and I don't know how to interpret this one. Okay, there are many things. Otherwise, unless there is a Faraday, nobody knows what is the force developed due to the charged electron moving into, isn't it? The electrons passing through a conductor. Where is the force? I can't see explicitly a force. The great Faraday could think a new force, and which is what is called a EMF, electromotive force, and that ordinary people cannot judge it at all. That's how you need to have a more simple definition between these particular two things. Now you see, first I'll take the battery. Whatever effect crossing the battery, I'm giving it to an electric motor. To the electric motor, I'm connecting a pulley and a weight. Now you see this one, the sole effect crossing the boundary of the battery can be used to raising of a weight. So according to thermodynamics, by connecting a motor and pulley, all the effect which is crossing the boundary of a battery can be translated into raise of a weight. So it looks like even the battery is also doing a work. Though the battery, whenever I see the battery and connected battery, I don't see any force, displacement, etc. Thermodynamic definition says that it need not be raising of weight always. But whatever may be the effect crossing the boundary, that can be, if I wish, can also be used to raise off a weight. I may or may not use always to do the work. So that is the greatness of thermodynamic work. Now you see, on the other hand, there is a rise. Okay, so that's how this definition should be discussed thoroughly. I'm coming with this one. So there are three terms which I italicized and bold. The first one is soul. What is the meaning of soul in the definition? What is the meaning of external to? And the third is could be reduced to, not actually only rise of weight. There are three terms which are very powerful, which makes thermodynamic definition and which made the people like, if this definition was available in the 16th century, perhaps Thomas Savery wouldn't have been thrown out of army, and he would have given a lot of funding to do that work as early as possible, and we would have invented maybe entire thing 100 years before. Okay, so a small definition and thinking is very important. Nowadays we can think everything granted. The first one is the soul effect. The soul effect means 100% of that effect which is crossing the boundary, which is happening due to the process. That 100% should be translated. That is the first point, what is called a soul effect. The second one is external to, very important. You need to calculate system to surrounding. What is happening within the system, that is none of our business. What is happening within the surrounding, that is also none of the business. When the system to surrounding means there has to be explicitly launcher, missile, explicitly the battery and the convector. There has to be system surrounding. And what effect which I am taking, the effect which is outside the system, external to, means only at the boundary. Within the system there is nothing like a work. Okay, very important. So the thermodynamics definition talks about unless there is a system and surrounding, you can't define a work transfer at all. Okay, one has to know. You imagine if I am throwing this particular one, I need to know who is system, who is surrounding. Okay, very important. Without knowing that, perhaps nothing can be done. The third one is could be reduced to. So there is no rule that every time it should be force into displacement, and it need not be always raising of weight. Unless there is a raising of weight, unless there is a force into displacement, I cannot call it as a work. Only if there is a force into displacement, then only work, otherwise it is not a work. No. So the effect could be anything, but that effect, no, the 100% is equivalent to raise of a weight. So there is no rule that there is a force into displacement. A boat can be driven a wheel. The wheel is rotating at some RPM and developing a torque. This entire torque into speed, no, equivalent to the force into displacement. Then what is the big decision? You don't have to capture 100 slaves, beat 100 slaves who will row your boats again and again, kill them literally. That is not fair. If I don't understand, so you can have a wheel, the wheel can be rotated by anything. Perhaps I can have a windmill, that windmill can rotate the entire wheel. Now I don't have to depend upon many people. Instead of having thousands and thousands of curtains, which will try to stop the wind and get pushed, which is ridiculous. What can I do? I can have a big windmill which will take the wind power, generate a torque. The torque is used to rotate a wheel. The wheel will apply the force into displacement. Because why? All of them are equivalent to raise of the weight. Whatever you are getting is equivalent to raising of a weight. Very important. It looks like obvious, but if you take the amount of this one, any unknown action can be converted into, it means I don't know whether there is a force and displacement, but I can construct in such a way that is it equivalent or not. Any questions? No. Okay. So now you see, if I have an unknown action, I want to know whether it is a work transfer or not. What is that? I am giving you this particular thing. Let us say I have a closed cylinder with some water at some temperature, inside which I am dropping a hot copper, very hot copper. Obviously from the copper to water there is some action happening. Because it is a hot copper, water may become very hot, the way we discussed in the last class. So corresponding to this pressure there is a saturation temperature. When the water temperature crosses the saturation temperature, what will happen? There may be a bubbling and boiling, etc. Now the question is, whatever transferred this particular one and generating a steam, can I call it as a work transfer? I don't know exactly whether what is it. Suppose we know heat transfer by chance, but thermodynamics want it to be known perfectly. Suppose let us say, let us use this steam and give it to a turbine. This turbine will rotate a motor, isn't it? Or a generator. This generator should be, can we use it to? Now you see, the steam is entering the turbine, leaving the turbine. Because of that, it can drive a generator. And generator is supplying the electricity. Now this electricity is same as that battery. So instead of that battery, I can use the generator to run our convector, the same convector. Now the question is, very interesting part of the entire story is, this entire elaborated system also developing same as the battery. Can I say what is crossing the hot copper is same as what was crossing the battery? The magnitude of this one and the magnitude of this one will be same. Okay, this is the one you can look into. See, I'm doing the convector in a long way. I have a hot copper block. I'm dropping the hotter cloth inside a water tank that is giving a steam. That steam I'm using to drive a turbine. A moving turbine will drive a generator. and the generated electricity I can use it to the converter. So such a simple battery is replaced by so many things. Can I say whatever crossing the hot copper block is same as whatever is crossing the battery? And how do you justify whether it is a work transfer or not is the one which is very interesting, and I request the teachers to explain this one, why what is crossing the boundary of the copper block cannot be called as whatever is crossing the battery. You need to say that uh, whatever steam produced that cannot be, Soul effect cannot be converted into this. Now I am giving the definition of negative work, because the definition talks about the positive effect. When a system does a positive work, its surrounding will do the equal quantity of negative work. That is very important. Suppose if the system does a negative work, surroundings will do the positive work. Okay, so one need not have a separate definition for this. The conversely, when the surroundings do a positive work, the system does equal quantity of negative work. Okay, so the positive work and negative work are equal, always exist together. Now you can see I am giving a big sequence. I have a electricity supply. This electricity supply will do work on the motor. The motor will do the work on the fan. Fan will do the work on the air. Now you see this particular one, because of which air is flowing through. So if you see this one, when I take the motor as a system, there is a negative work of the motor and positive work is done by the electrical supply. When I take the motor and the shaft, this particular fan, the motor is doing a positive work on the fan is having a negative work. When I take the fan and the fan is doing a positive work on the air and air is doing a negative work on the entire thing. So thermodynamic definition, whenever there is a system and surrounding, if the system does a positive work, obviously surroundings are doing negative work. If the system is doing a negative work, positive work, then surroundings will do a negative work. So it looks like there is no need to define the negative and positive separately. If one does the positive, automatically there is a negative work. So the entire definition has so much. What is the important thing is there should be a system and surrounding. System should change its state, then the surroundings will get the benefit, and that benefit which can be equivalently transferred to the raise of the weight are called work transfer. If the sole effect is not equivalent to the work transfer, it could be something else. What is that something else? And we'll discuss in next class. Some more examples of work transfer and another important happening which is essential for thermodynamics. Once you learn these two, you will get first law of thermodynamics, very essential for modern engineering. Any question? Audio not clear. This is very important aspect of this one. So in order to define the system or a work transfer, you need to be very careful that there has to be a system and surrounding. Suppose if I take the missile launcher and the missile both together, same system, nothing is happening. Whatever energy of the launcher given to the missile only, everything is within the control volume, nothing is happening. So you will think that there is nothing happening at all. So the total energy and the total state of the system together nothing happening. It is after all, you are not differentiating the missile and missile launcher. If the missile and missile launcher are together, there is no change of state at all. How do you define the change of state? It should lose something. It's a pressure, volume, temperature, or anything equivalent should change. Unless I separate the missile and missile launcher, I can't see the work transfer at all. I can't design a missile launcher and a missile. So in order to design the entire thing, no, you need to have a missile launcher separately. So once the missile is launched out, you cannot say that missile launcher and missile are together. How can you say? Before start, missile is inside the missile launcher. They are together. But whenever I want to give some kinetic energy, some motion to the missile, you have to separate. If you don't separate, you are doing nothing and you can't design a system at all. Okay, in order to design what should be the size of a missile launcher for a given missile. Suppose if I want a missile to travel 1 kilometer, what should be the size of missile launcher? If I want a missile to travel 2 kilometers, what should be the missile launcher capacity? Suppose if I have a missile launch of some capacity, if I put a missile of 200 kg, how much distance it can go? If I put a within the same launcher, if I put a missile of 1 ton, how much you go? So unless you separate a missile and a missile launcher, there is nothing you can design. It is a matter of just a fun. So if you want to develop a product, a missile and a missile launcher have to be separated. If you think them together, no, you do nothing, no engineering at all. They cannot be separated if you want to analyze. They have to be separated if you want to analyze. If you don't separate them, you're not creating any product at all. Something is happening, I'm looking at it, that's all. Entire planetary system, somebody can think as a one, nothing happening. It nothing happen. Earth is going around the sun. It is a planetary system. Nothing is lost, nothing is gained. Okay, you separate the system and surrounding. In fact, no, the definition says that you need to do that one if you want to be a designer. Not separating means you are not doing anything at all. Okay, thank you very much.